Hey guys, sorry I can't be there today. Turns out surgery takes more out of you than you think it will. But what I'm going to try to do is run you through the basics of today's lesson so we don't get behind in the schedule. If you have questions about this tomorrow, obviously feel free to ask. But hopefully this can kind of get us set up where we can hit the ground running tomorrow with what we need to do. Now, the objective for today's lesson is we are going to be learning how to rationalize the denominator. Now, rationalizing the denominator is kind of a strange thing if you don't understand the concept of why you're doing it. So I'm really today going to try to drive in not only how to do it, but why we have to do this. So let's get into this. Rationalizing a denominator means that we need to take a denominator. So let's say we have radical 7 over radical 3. I cannot have an irrational number, which hopefully you all recognize that radical 3 is an irrational number. I can't have that in the denominator of a number. So the basics of what we're going to go through today are how to fix that and why it doesn't work. Now the key steps here, a fraction can never contain a radical in the denominator. If there's a radical anywhere in the denominator, we need to rationalize it. Now rationalizing means to convert an irrational number into a rational number. So rationalizing means converting it from that irrational state into a rational state through some mathematical manipulation. It's actually very simple to do, but again, as we've learned with radicals, things that seem simple at the outset actually end up being a little difficult. So what I want you to do for now is you're going to, if you have not yet done the do now, do the do now really quickly, pause, do the do now. If you've already done the do now, go ahead and watch. I remember that my first step in these cases is always write y equals mx plus b, and we know it's an inequality, so this equals is not going to be an equals in a moment. So y, well, I shaded beneath the line, so y is less than, it's a solid line, less than or equal to, let's zoom in. 8 is my intercept, and it appears to go down 2 over 3. So y is less than or equal to negative 2 over 3x plus 8. And again, hopefully that was reasonably simple for you. If you had trouble with that, feel free to ask Ms. Sharon or myself when I return tomorrow, because we cannot be losing those basic skills. Let me not erase all that. We cannot be losing those basic skills through this unit because you're going to need them in the next unit. Now, coming down to the fluency, I'm going to do a few of these with you, but hopefully you can do these on your own. So I'm going to do this column worth of them. What I want you to do right now, though, is quickly pause your video and give it a shot on your own. All right, so we're back. We're going to go through this. I know this breaks down into radical 9, radical 2. I scribbled this out. Radical 9 breaks down into radical 3 and radical 3. Scribble this out. Circle any pairs I have, so I have 3, radical 2. Let's go to this one. First step, I break them into their component parts. 8 breaks down to radical 4, radical 2. That's gone. 4 is 2 and 2. So I get 2 radical 2 out of the 8, and then the x squared, hopefully you recognize, just becomes x, but if you don't see y, it's because I get 2 x's out of it. So my final answer over here is 2x radical 2, because this x came out and this 2 came out, so they join together and the radical 2 stays by itself. Clear up a little space because my handwriting is awful. 20 breaks down into radical 20 and x 3. So 20 is 5 and 4. 4 is 2 and 2. So the 20 becomes 5 radical, or 2 radical 5. What am I talking about? 2 radical 5. It is entirely too early. 2 radical 5. And x breaks down into x, x, and one more. 1x comes out. 1 stays inside. So 2x radical 5x. 2x radical 5x. X to the third, we know, breaks down pretty simply to x, x, and x, which becomes x radical x. And 12 breaks down into radical 4, radical 3, which hopefully you're starting to memorize some of these. Saves you a significant amount of time in the long run. There we go. Now, to get into rationalizing the denominator, what you're going to do initially is I'm going to pause the video, you are too. You're going to go into where the investigation says without using a calculator, complete the following division problems. Hopefully you remember how to do long division. If you do not, the basics are, I just wrote a radical, definitely too early. You're going to put division, the 3 goes on the outside, and on the inside we get 358.5. And then remember, the decimal just comes straight up. So I'm going to let you deal with this for a few minutes. Once you're done, come back and we're going to talk about what it's like to do both of these problems. And over here, obviously, we would have pi on the outside of the division symbol, and on the inside we have 600, or 6,350. Go ahead, pause the video, give it a shot. All right, hopefully you realized that these are reasonably easy bits of division, such that we have, that goes in once, gives me 3, 0, 5. 3 goes into 5 one time as well, with the leftover of 2. 3 goes into 28 9 times, which leaves me 1 left over. And 3 goes into this 15, 5 times 2 would have gotten 119.5. And if the long division there without me actually writing out each of the steps is baffling you, we can talk about it tomorrow. It's not actually the main focus of today's lesson, so I'd rather not spend any of our precious time on that. Over here, though, we recognize we can't divide by pi. We have to write that in its traditional numeric fashion. And again, it says pi. It does not, note, say pi equals 3.14. It does not say 3.14. So what it wants me to really do is, in order to do this division, I'm going to have to write this thing out. So I say 3.14159, and hopefully you see pretty quickly that that doesn't make much, not radical, that doesn't make much sense. I'm going to try to write all of the digits of pi, and once I'm done writing all the digits of pi, then I'm going to write 6,350. So what's wrong with that? Why is that problematic, or is it problematic? Well, hopefully what you recognized is I can't do this division because I literally can never finish writing the problem. It's impossible. I can't write the problem, so if I can't write the problem, I can't do the problem. Whereas over here, I could write the problem pretty simply. There's only 5 numerals in the entire thing. Whereas over here, there's 4 numerals inside, but in the divisor, there's an infinite number of numerals, so I literally cannot write the problem. And if I can't write the problem, I can't solve the problem. So, which of the above division problems would you prefer to evaluate with a calculator, and why? Well, obviously, I would prefer to evaluate, you can write this down. I would prefer to write and solve problem A because it's, well, functionally possible. That leads us to this. Come down to the investigation part 2. Rationalize this denominator. You're going to use a calculator because, again, as you just learned, it's impossible for you to do this in your head. And I want you to calculate radical 7 divided by radical 2. Give us a basic decimal approximation of it. And from there, do radical 14 divided by 2. Not by radical 2, just by 2. Same thing down here. Give those a shot. We'll come back together in a moment. Pause the video. You got for this first one 1.87-ish. And here you also got 1.87-ish. And you would have also noticed that down here, you're going to be getting the same numbers as well. If you did not, I'd go back and just check exactly what you did on the calculator because unfortunately you had a misclick somewhere. Now, what do we notice about both decimal rows or decimal values in row 1 and 2? Well, there. Use the proper version of there, please. They're the same. How could I transform column A into column B? Well, that is a process known as rationalizing the denominator, and it's actually very simple if you are careful. Now, if you're not careful, just like all things with radicals, you're going to throw an errant radical in somewhere. You're going to forget a radical somewhere. It's not going to work out well. Now, how do I transform the expression in column A into the one in column B? Well, I follow these exact steps, looking back at the very top of your paper. In order to do this, I just sounded a lot like Khan there. In order to do this, multiply the numerator and denominator by the radical. Then simplify to simplest radical form. So I'm going to say multiply numerator and denominator. Feel free to rag on my writing all you want. Multiply numerator and denominator. I can spell denominator by the radical. And I'm saying the radical because it's always going to be by the one in the denominator. Then simplify. Now, I told you the things you're always going to do wrong on these. I'm going to come over and I'm going to give you an example here. Radical 7. And you don't necessarily need to write this down because you're going to practice it in a moment, but I'm showing you this process here. Radical 7 by radical 2. First thing I think to myself is, well, is this okay? And we happen to see that it is not because there's a radical in the denominator. And if there's a radical in the denominator, then this is, shall we say, bad news bears. It is ugly, also known as Steve. And it is wrong. Kind of like my assumption that I was going to be there today. This cannot happen. So I need to do a process known as rationalizing the denominator. And again, I can't do this because I can't finish writing radical 2, as I'll show you. In order to do this division, I'd have to say, well, what am I dividing by? Well, I'm dividing by that mess. And it's irrational, so I can't finish writing it. If I can't finish writing it, I need to fix it. So I'm going to multiply this by radical 2 over radical 2. Now, I'm sure some of the particularly nerdy among us are wondering, well, why can I do that? I can't just go and multiply or divide by whatever I want at any time. That doesn't make any sense. Math has rules. We have to follow them. But hopefully you notice you're not actually multiplying by anything because radical 2 over radical 2 is equal to 1. So I'm not actually multiplying by anything. I'm simply redistributing where the radicals are. And if I'm redistributing where the radicals are, then I can divide. So what's radical 7 times radical 2? Well, it's radical 14. Hi, G. And here we have radical 2 times radical 2. Well, radical 2 times radical 2, hopefully you've recognized this by this point in time. Radical 2 times itself would be radical 2 squared. And a square and a radical cancel. So I end up with just 2 in the denominator. Ladies and gentlemen, that is my rationalized fraction. That fraction is now rational. I can now do that division. As cumbersome as it may be, I can now do this division in a meaningful way. I've now rationalized this denominator. So let's try the other one that was over there. I believe it was radical 13 over radical 5. Again, you don't need to do this one. You can just watch. We have radical 13 over radical 5. I can't do this because I have a radical in the denominator. Therefore, I need to redistribute some of this by doing radical 5 divided by radical 5. So all of this times radical 5 over radical 5, which again doesn't change the number. I can do this because radical 5 over radical 5 is really just is really just equal to 1. So if it's really just equal to 1, I can multiply all I want by it. And I'm not changing the problem. Radical 13 over radical 5 is equal to radical 65. Radical 5 over radical 5 is equal to 5. That is now rationalized. I cannot simplify 65 anymore because it's equal to 5 and 13, both of which are prime. So I can't do anything. This is done. So here's what you're going to do with the remainder of class, because you don't have that much time left. You're going to break into your groups. You're going to either do your sigma or phi. And by break up, you don't need to move. You're just working on your leveled practice. Sigma and phi. I'll put the groups up on the screen really quickly so you can figure it out. You're going to work on these. At 12:30, at 12:30, keep an eye on the clock, you are going to transition and do your mastery check. At 12:30, I will be collecting all of this. Actually, you're going to give this to Miss Sharon on your way out the door so that I have it tomorrow morning. I'm coming in early so that I can actually make sure I can get these graded and in the gradebook for you. Another quick note, I heard a lot of really good reports from the sub. There were a couple names that came up, and I want you to really strongly consider if that was the demonstration of everybody's best work. From what I've heard, it was a demonstration of all but 2, potentially 3 of yours best work. Please take this seriously. This is incredibly important and will pop up quite often. In addition, I am trusting you. Please be cool. Get your work done. I miss all of you. I will be back tomorrow. And if you have any questions, feel free to email me. All right.